Hello, hello. Welcome. Sorry about the slight technical glitches we've been having over on our side. It's been joyous. You will probably see me experience some widgetiness this morning. Hello and welcome to Qualcomm streaming. Today we are doing a live build along session with Docker and the Qualcomm RB3 Gen 2. My name is Rain Leander. I am your host, and without further ado, I want to bring on Raul, or if you speak Portuguese, it's Raul, which I do not speak Portuguese, but I will do my best. And we're all doing our best today. That's basically the point of today. We're doing our best. Raul, talk to me about yourself, what you do here at Qualcomm, and yeah, welcome.
Well, thank you very much for the opportunity, Rain. It's a very nice opportunity to share a little bit of what I saw during my career when I started learning Docker container for embedded. And then just about myself, I have been working on embedded for about 15 years. I worked before as a field application engineer at Turadex, where I work with a lot of customers, helping them to doing their own projects. And then I started work for Foundries about 6 years ago. And recently, as you might know, or a lot of people should know, that Foundries was acquired by Qualcomm a year ago. And at Foundries, we have been using containers since I start, and that changed a lot my view on Docker container. And the idea of this talk is, and also this presentation, is really helping someone who have never used Docker, someone who is playing with microcontroller, with Linux, but have never playing with Docker, to get started with. And basically, it's hard because a lot of people see Docker as something for cloud PCs, for cloud development, cloud software development. But actually, it is really used for embedded right now, and it's a tool that can help you to make a lot of cool things. So I want to show a little bit of that today and help someone to get this first initial idea.
I want to ask, Docker has a bit of a reputation, like people love it or hate it. I feel like people who have never heard of it are a little bit intimidated. Can you talk to me about the ease of use of the developer experience for using Docker in particular?
Well, I think Docker has the same idea of this AI. AI before, it's something that you have to have big servers, big PCs, right. And then nowadays we have AI on your phone. You have AI everywhere in a camera or anything that watch it. And Docker is the same. Like Docker was made to facilitate the development, the cloud development, and the big PCs development, where you have something that you can easily reproduce the same environment in other PCs and very quickly escalate and so on. And then, but if you see the embedded development nowadays, we do have a lot of PCs, very powerful PCs on our desks. And the same idea is you might, if you are developing a device, you might want to have all your devices running the same software all over the place. You don't want one device with one version, another device with another version, and then you have a mess in your fleet. So the idea is really, it's easy to reproduce. It's easy to change when you change your board or your device. It's easy to reproduce in another device. And also it's easy to make it uniform in a way that you can have a better and easy way to manage your fleet.
Yes, love it. And talk to me about Foundries. What does Foundries do?
Well, that's a good question. Well, Foundries was initially created as a spin-off of Linaro.org. And if you are not familiar with Linaro is where all the vendors like Qualcomm, NXP, TI, you work together to make open source for ARM device. And then what the Foundries saw is they want to help also not just the big vendors to do open source, but also how they were thinking how to create a company that could help small companies to do embedded development right. And then they create Foundries IO as a company. And basically our main software and our main product is a software as a service called FoundriesFactory, where we help companies to do development since the CI/CD and since the defining the architecture to going for production. We cover all the steps and we help out in all the steps to have your device successful in the field. So this is about Foundries. And then we were created 7 years ago. And like I said, we were acquired by Qualcomm a year ago, and now we are part of the Qualcomm group.
Amazing. Welcome. I hope you're having fun.
Yeah, it has been fun. Yeah.
Speaking of having fun, go ahead.
Well, actually, I want to say that it's of course Qualcomm is a very big company, and then they are making very nice. They are being nice with us and making us still behavior as a startup, as a small company. Yeah. So even we are part of Qualcomm, we are still a separate entity where we can do our stuff and do our work. So I think it's cool, and I have seen Qualcomm acquire other companies, and I think they are doing that for all the other companies. They are not acquiring for making this just now it's Qualcomm. It's more like how we can work together in IoT industry and make it right. So I think they are doing a very good job on that.
Yeah, amazing. All right, speaking of having fun, let's get to your live build along. Are we able to share screen?
Yeah, I will share my screen first. I will go over 5 slides. I just for everyone listen. If you wanna reproduce the steps, like I said, this is a get started for someone who have never played with any Docker. So you get started from a hello world to something more like a web app inside a RB3. But I'm running everything on our RB3. But if you have any other device you want to play with, as long as you have Docker installed, or even on your own PC, you can reproduce everything that I'm going to play with. And also, I share a document on Discord where you can have all the examples there and copy and paste and follow all the things I'm going to do today.
Perfect. And we are going to add that link to the description of the stream once the stream is over as well.
Okay.
Let's hand it over to you. Go ahead and share your screen, and I will get it up as soon as I see it. Yes? I can also make it slightly different. Well, we don't want to talk to me. We want to talk to you. So give me a second.
Let's see how it looks. We have to clean a little bit. Actually, for this one, we have to clean a little bit.
We can also do this.
Yeah, that's perfect.
Completely, yeah, cool. I'm gonna remove myself a little bit from the screen so you can be the star. Take it away. Okay,
so first, I don't want to talk too much about me again. Like I said, I have my LinkedIn link in the screen. If anyone want to add me on LinkedIn, happy to create this connection. I already mentioned what we do at Foundries, but I want to quickly read that sentence. We enable OEM device makers to accelerate building Linux and AI-based edge products with lower development, maintenance, and management costs. And like in other words, we try to make things easy for you that is developing something with Linux and want to make it right, adding all the security, doing over-the-air updates, maintaining your Linux, and so on. And how we do that, this is a little bit of what we do as a product. We have a product called FoundriesFactory. It's a CI/CD platform in the cloud that you can build Linux and containers, and then you can also manage your devices. You can do waves when you want to update a large fleet of devices, things like that. I will give you a really quickly walk through the FoundriesFactory so you can see how it looks like as well. And then I want to go over containers, and why I want to go first, like I will go to this slide and then I will stop and show FoundriesFactory in a moment. But basically, before I worked for Foundries, I believe my belief was that when you are doing embedded Linux device, you have to have full control of your distribution and everything should be on your control. So I was really fan of Yocto and have everything inside Yocto. But then when I started learning container, Foundries have this architecture where you have a distribution built with Yocto, you make it as simple as possible, you make it secure, and then you can play your apps over containers. And of course, if you want to have one app in the Yocto because maybe you need a real time or something more like close to distribution, you can place that app there. But there is a lot of things that you can do on the containers that is really cool and that doesn't need to be into your main distribution. And the example in the screen is you have this embedded distribution created by Linux, and then you can have a ROS application inside the container, and then in this ROS container you can have Ubuntu or Debian or whatever you like. Yeah. And then you can have an AWS IoT, and you can have web servers, you can have any app you want. And then I want to show you in the FoundriesFactory how we deal with that.
Cool.
So FoundriesFactory, this is our UI. If you see all the squares in here, it's a sandbox where it's an isolated place where each customer or each partner can create their own factory. I'm into a lot of squares because I'm, of course, in the marketing, and then I have a lot of demonstrations. But usually a company will have one or two. I want to show you this demo AI, the one I will be playing today and showing some cool demos. This is your first view where you can see how many devices you have, how many tags. This is a simple factory because it's just a demo, but you can have as many tags you want. You can have a lot of branches and develop a lot of different codes in parallel. And then when you are happy, you can merge it back. Then when you see targets page, this is where our CI/CD makes things start to get more interesting. If you see in the page number 2, every platform main, it's a Yocto build for the RB3 Gen 2. And then every container main, it will be a container build. And what we do and what's really cool is, let me open one here very quickly.
Okay.
Come on.
It's always slower when you're doing it live, by the way. The laptop is like, wait, I'm shy. By the way, if you have any questions for Raul, I'm going to keep practicing. If you have any questions for our amazing FoundriesFactory engineer, Raul, please feel free to put them in the comments. And it looks like we are having sound issues over on Discord. I see you, Stone. Thank you for letting us know. In the meantime, encourage people to come over to YouTube if this is working. Go ahead.
Well, I was saying, like, when we build a platform or when we build a container, what we do is, if you are building a platform, we rebuild the Yocto, and then we regenerate the hash here, and then we put that hash together with the previous container build. And then when we build the containers, we rebuild the hashes for the containers we change, and we use the previous Yocto hash. And what that means is a device running the version 10 will be always running this Yocto with this container. And that's really important because you always track together like Yocto change and container change, and then you are sure that this version is the one I test, this is the one is in production, and that's working. So you see a lot of people nowadays playing with container. They have a team working with the Yocto or with the distribution, and they change the distribution, and then another team change the container, and out of the blue, nothing is working anymore. Like, and then the reason sometimes is this is not wasn't developed synchronized, like there wasn't like a communication between the platform and the applications team. And with FoundriesFactory, we always tie together because we trade it both as the same thing. And then of course you can change the container and the Yocto as much as you like. For example, if you go back to the target page, I have been changing containers for a long time, but as soon as a platform changes it will have a new platform with this the latest container, and then you test that version, and if you tested it is working, there is no reason to be afraid that's working, and you can go further. So just moving further, We also do bill of material. Every single build we do, we generate a list of the software, the software using in each container and each Yocto distribution. And also, you can connect as many devices as you want, and then you can deploy the containers remotely. So, for example, I have this RB3 AI1 in my desk right here. I can try to move my camera and show the device in here.
Yeah.
This is my device. It's online right now, and as you can see, it's running one container already. And I want to do the opposite. Instead of going to audit class and then showing a demo in the end, I want to show the demo right in the beginning so everyone can get excited and see how it works. And then if you want to follow the steps and get to know how you can get there, you can just follow the live today. So as you see,
I have a quick question from the public. What's the minimum resources for the host machine? So not the device, but the host needed for the container we're using for today's build along. Just want to figure out which machine to use to build along. Great question. Thank you.
Oh, that's a good question. And basically, Docker doesn't give you a big overhead in terms of memory in general. But what is important to mention is, for example, we have a customer running on a device with 500 megahertz of processor, and how was that? It was a device from we also support NXP, so we have a customer using an iMac 6 ULL, which is a very tiny device, and this device has 512 megabytes of RAM, and if I'm not wrong, it's like 1 gig of flash. And the thing is, you have to have a more flash for sure, and more than like having like a named flash with just like 128 megabytes or something like that. I mean, once you have like a gigabyte of memory, or flash memory, and 500 megabytes of RAM, you probably will be able to run that. And I mean, most of these devices running cameras, AI, and things like that will be able to run a Docker. So yeah.
Very cool. Very cool.
Jumping back to this, like this demo is running this Edge Impulse CLI, and I want to show you if I change my screen to my terminal. This is my RB3. If you see, it's my serial. What I'm going to do right now is I will open a terminal and do SSH so I can have a better view on that. So if I do Docker PS, you can see I have a couple of containers running. This was some example I was playing before, but the one I want to show you is this one, which is the one managed by FoundriesFactory. And if you see, it says CLI Edge Impulse. I want to show you that Edge Impulse, what this container is doing is it's connecting to Edge Impulse, and it's live streaming this camera right here. So if I see my device in here, this is my device streaming that. And the cool thing is I can start sampling this and getting more pictures to my database. And that's also, Edge Impulse was also a company acquired by Qualcomm a couple of months ago. And the cool thing is I can easily acquire data here. I can very easily put the bounding box and square like with person in here. So I can do one right now. Let me do this one at label.
Doing training on the model, literally live. That's amazing.
Next. And this is a container. This is the beauty of Edge Impulse. I will show the beauty of Foundries of replacing this container and adding another one. So what I'm going to do right now, I'm not going to retraining the model because it takes some time, and not going to deploy this new model, but I'm going to change the device to something, to an application that start qualifying the image live. So I'm going to change this device. Oh, what's happening with my internet today?
Yeah. Here
we go. Update tag. I would say replace this container to this one, object detection, and people assets. This one. And then I need to have a two-factor authentication. Here we go. And then if we go back to my device, we have a daemon in the device who does all the updates, not just for the distribution, but also for the containers. And what my device is immediately doing is saying, oh, replace the container for this, to that. And then if I show you this is my screen plus the device HDMI output. The HDMI output is in the background, and this terminal is the same terminal we are seeing right now. We will see the application going live very soon. Here we go. Now we change the application, and it will be back in the background in a second. Here we go. So I will open my OBS in another screen to change. This is the device HDMI output. So if you see, it's recognizing person live. And the beauty, I mean, don't worry too much about the, oh, let me get this back. Don't worry too much about the squares. Like sometimes not getting the right square, but I mean, it's just to show the ability to replace an application, showing like you can turn off on a container and turn on another container immediately, and you can change completely the device behavior without rebooting the device. And that's the beauty of container, and that's the live demo. But now I'm going to go back to this, and I will remove all the containers because we have some work to do. And then if we go back to the terminal, device will now remove all the containers that we just remove from the UI. Now here we go. And then now just the containers I was playing is here. Okay, cool. Let me clean up this one very quickly. This one and this one. Okay, cool. So should we get started? Ryan, do you see any questions? Let me quickly look. Hey. Okay, I see one question, a very good one. What OS is running on the RB3? And let me get my. So basically, what OS is running is the Linux microplatform created by Foundries. It is a Linux distribution, very optimized for embedded devices with focus on security. So most of the file system is read only, and that's a very tiny distribution to support like all the FoundriesFactory and so on. And on the FoundriesFactory, one thing that is important to mention, we allow the customers to create out their container application, but also customize their Yocto distribution on top of the Linux microplatform. So that's the OS running on the RB3, and also the Linux microplatform includes the partner layers, so it includes the Qualcomm meta layers to support the RB3. So we are also using codes from Qualcomm, the layers from Qualcomm in the open source to support that device. So going back to the container, like I said, container it's a isolated way to have an application. It's lightweight, standalone. You can have each container will have the packages required for your application. You can start a container from other knowing distribution like Debian, Ubuntu, Alpine, and things like that. And yeah, that's I already covered that. And Docker, I want to talk about Docker and some words that you might listen when you get started with Docker. You will hear a lot about Docker Engine, and Docker Engine is the daemon installed in the device to play with Docker, the REST API, and the command line interface to run Docker images. And also, Docker images will be a file that will describe your image, your Docker image. So basically, when you want to create your Docker application, you have this Docker image to describe everything you want to install, and then when you build that, it will be your Docker image creating your Docker container. So your Docker container will be the runnable instance from that Docker image. We will see that in a moment.
Mhm.
And then a Docker registry is, if you see Docker Hub, for example, you can upload your Docker containers, and
Mhm.
then you can download that image from anywhere. And the Docker registry is the responsible for doing that, hosting that image and making it available for you update any device. So an example of a Docker image, one thing that is important to mention, Docker image is created in layers. So when we create a Docker image, every single line that you write will be a new layer.
Mhm.
And then what that means is, if you go, for example, this example from Ubuntu, you are starting from a package with a lot of layers that was made before. And then as you increase your steps, you are adding more layers. So one thing that is important for IoT and IoT device in general, if you want to do minor changes on your Docker container, as up in the file you change, more you have to rebuild everything that goes next, because it's like it's one line depends on the next. So for example, if you want to install something like this apt-get python 3, and that's something you install and you are going to use forever, that's fine to be in the beginning. But then if you have small packages that you are changing all the time, it's more likely you put in the end of the file, so you just change the last layers, making the update lighter. And also base image is, like I said, where you go from. So for example, from Ubuntu 20.04, it means you are starting from an image that like Ubuntu 20.04, and that means everything that is built into the distribution will be available in that Docker file, in that Docker. So for example, if the Python 3 was something that was previously installed on the Ubuntu, I don't need to run apt-get install and install the Python 3. It will be inside here. But in that case, it wasn't there, and then I have to install it next. Then this file that we are saying, this Docker image, is named as a Docker file. The Docker file will be the file responsible to describe your Docker image.
Right.
And like I said, register will be where you store your Docker images so devices can download the image and run. Well, that's not thank you yet. Let me go back to this, and I will start playing with my device right now.
Okay, I have another question from YouTube. Prince Patel wanted to know if Foundries supports OTA upgrades.
Absolutely. Yeah, that's basically one of the
Yes.
main things we do. Well, basically, why we do OTA is a good thing, like a good question. Like, a lot of people think as Foundries as being an OTA solution. And actually, OTA is one of the features you have to be nowadays secure, maintainable, and do things right.
Yeah.
So it's not that we do OTA. We need to do OTA if we need our customers to have the possibility to avoid a vulnerability, to avoid something that it could cause a risk to their customer. So the customer don't need to use that, but being there, it's something that it's important to. If something really bad happen, you have the ability to jump in and replace a package or so on and so on and so forth.
Yeah.
So we say that because a lot of companies, some people, they really want to update because they are adding more features and make it cool, but it's not just about making it cool, it's also about security. Some companies doesn't want to really touch the device anymore. They do once, so they say, I will never touch that again. But then nowadays there are some legislation that is pushing that will be pushing companies to have the control to update if some kind of vulnerabilities show up.
Absolutely.
So you have to be prepared.
Agreed.
So back to my device, what we are going to do right now, it's basically doing a hello world, and then I will show you a multi-stage container and why we should use multi-stage, and then we are going to do a web server as well in a different container, and then finally we'll show you this container that's running already here. I'm not putting them down because it's basically acquiring data from the processor and from the RAM. So I can show you the graphic. It will look better when I show in the end with more data instead of just turning it on and doesn't have anything. So first thing first, let's do a hello world. So to start, I will create a folder here, make hello, and let me also see some notes on my side here. Okay, first thing first is we need a hello.c file. So I'm going to do a very basic hello word.c file, and I'm not going to waste people's time typing out the lines, but basically we are doing a hello word, a C hello word. That's everyone can get it, right?
Oh, thank you.
Thank
you for making it bigger. Yeah.
So next is we need a shell to start something. So different than a distribution, when you turn on your PC, your Linux distribution could be Ubuntu, Debian, any distribution of Fedora. It opens a lot of software at the same time. You have a system that opens a lot of things. All the PCs is like that. A Docker container is different. You have the required packages to open your process. So our process right now will open this is start.sh, and this start.sh will do just the hello world. So your container will be closing this loop, and there is no other process being done there. So I could just do hello world in the background and start spin-off process, but that's not the way that Docker really works. It's more like if you have multiple processes, you should have multiple Docker images running different processes. So then you can really manage this process separately. So I will write down this one. Next is where things start getting interesting. I will create my Docker file, which will be the software description for my Docker image. So here we go. I will copy and paste this one as well. So what we are doing here is we are starting from a Debian stable Sling. So it's a Debian with more like Sling, like tiny or smaller.
Yeah.
And then what we are doing is we need to have build essentials to do GCC hello world C and build that application into a binary. So I'm doing apt-get update, apt-get install, and I'm installing these build essential files to have all the packages necessary to compile this C application.
Yeah.
Next, all these commands will be running when we do Docker build. When we do Docker build, it will jump into that image and will build everything and create these layers and create this Docker image. So the next command is inside the container, whatever this Debian image left me, and probably is in the root directory, I'm just making a folder into the root app. So in the root, if I go to my container, you will be able to see inside the dash app, that folder will be there. And then I'm copying, when I do copy like this, I'm copying the file from my host PC to the folder app. I'm copying my file start.sh to the app. I'm making the start.sh run command. Change mode is making it executable. So that file, I'm not sure if it was executable or not. Probably not, because I just write that down. So I'm making this internally to make a executable. And then I'm changing the directory. So from whatever I was to going inside that folder. It's mostly like a CD app. And then I'm running finally the command gcc c hello world and creating this binary. And finally, what I'm going to do is start from that script I just created, start.sh. And as you can see, start.sh will run the hello world, not the hello world.c, the hello world that we just create as an output of this file. So this is about the Docker file. Let's see this building. What I need to do now is I need to do. I was thinking if I can remove that part to make it cleaner, but let's do it right here. I need to do Docker build. I need to create a tag, so I will say tag hello C, and I will say this is my latest version. Oh, let me make it like this. And then I need to explain to the Docker build, where is my Docker file? And it's right here in that folder. So let's build it. It's quite quickly because the RB3 is also very powerful, but basically what we did is we get this image, we update that, we install the build essentials right here. Then we create a folder, we copy the hello world to inside, we copy the start, we change the start to make it executable, and then we build that hello world, and finally we define it with what is the entry point. And now we can just do, so what I did is Docker build tag hello world. That's what you need to generate your first image. And then we can run that Docker run it rm hello C latest, and then we have our hello world running inside a container. Every 5 seconds it will have a new hello world going up. And then I wanna show you something. What I can do right now as well is I can open another terminal. I will jump into the device as well. Docker PS show all the Docker running. We can see this hello world running right here because I didn't specify the name. It's saying a random name right here. And what I want to do right now is I want to jump inside the container and see what's in there. So if you see my device, this is my distribution. This is the Linux micro platform. You can see all in blue. You can see that a lot of file system is read only, pointing to the other directions. And then I want to go inside the container, Docker exec-it, and then I need to say, oh, my mistake, sorry, Docker exec it, and then I need the container name, and I want to go for bin bash so I can have a bash inside the container. Here you go. I'm now on the container. You can see this different name right here, and then I want to see how my distribution looks like. And you can see that it's a different distribution. This is my device. This is my Docker container distribution, and you can see that it's different. This is probably based on the Debian that we use it from. And I want to show you inside my app folder.
Yeah.
What I have is I have the C.c file. We have this start.sh, and we also have the binary file right here. So this is the first example. I want to show right now. I want to go and do a multi-stage container where we will jump inside here, and we will not be able to see hello.c because hello.c is not really necessary to be here. So imagine you have a huge code, and you are building, let's say, something like Chromium or something huge. You don't want to have everything that you used to build. You want to have just the binaries, the install packages. So that's where you use multi-stage container, that you can build everything in the first stage, and then just the binaries you can install in the second stage, and then your container will be lighter and better. So I will show the same example we did right here, but in the same hello world, but in a multi-stage. So I will exit to leave. I will exit again because I don't need the second terminal right now. I'm back to my terminal I was using. What I'm going to do is Docker PS. I already stopped the container because it was holding it here when I crashed this. It automatically stopped my container. Wasn't running on background.
Mhm.
Let's go back to this folder and let's create mkdir mode stage. Mode stage. We need to do again the hello world. So I will copy from the hello world,
Mhm.
and I will copy the start file as well. So we don't need to copy it again or write that again. But now what we need is we need a different Docker file. And I will also copy and paste this one so we make our life easy. So let's talk about this Docker file for a moment. What we have here is we have one stage on the top and a second stage in the second part. So the first stage is basically the same as we did on the single one. The only difference is we are saying as builder, because when we have this as a builder, we will be able to copy and use the builder in the next stage. And then everything else is the same in a way that we are building the hello world binary right here. And then we start that again, the Debian stage is lean as final stage. This has another name right now, final. And then what we are doing is we are not installing the build essential. And by not installing the build essential, this GCC will never be installed in the second stage. So when we jump inside the container, GCC will not be available. And then what I'm going to do here is just creating the same directory app. And then I'm copying from builder the hello world to this stage app folder. And then I'm copying the start as before. I'm not copying start here anymore because I don't need it here. I need it here. And then I'm making it executable. And then I'm starting from start. And let's build and play with this. So I need to do Docker build. I need to do tags. I will say move stage latest. And I have to mention where is the Docker file, and it's right here. Or I could use something like var root dir home file mode stage. Docker file is here, right? So I will point it to the path instead of use dot right now. So let's do like this. Here we go. We are building, creating the new stage, copying, all done. So everything we saw that before, it's right here. We are good to go. So we are copying from builder to the app hello world, just the binary. And now let's play this. So Docker run. Now I will name it so we can have a nice name. Mode stage. And then I will say D for daemon, for going in the background, or disattach. I think it's disattach the right word. And then I will run the mode stage. Oh, sorry, my fault. Mode stage. Here we go. Now it's running. So if I do Docker PS, we have mode stage running right here. And because I'm running on background, I can't see the logs anymore. But what I can do is I can do Docker logs. Here we go. I can also follow the logs if I want to hold it. Here we go. And then finally, let's jump inside that. So I will do Docker exec it mode stage bin bash. Here we go. We are now inside the container again. I can show you the file system is different than the previous one like before. But then now inside the app folder, I have just my binary and just start sh. And also I don't have GCC here installed. I forgot to try GCC before, but on the first one, GCC will be available for sure because it was part of the Docker image. So that's about the mood stage. Let me exit this one. Oh, let me get back here. So let me pause for a moment and see if we have any question.
We do have 2 questions. One is from Discord. Start sh is the Docker configuration file. That's literally what was written, but I think, is the start sh a Docker configuration file?
No, it's the shell script responsible for running that application. It could be, so for example, what I could do here, if I go on, let me go on hello world. VI Docker file. So basically, this is the starting point. I want to run that script when I start, but basically I could do something like echo hello. Oh, hello. Let me see if that will work. Build. Now I'm not using.
We do have a second question as well when you're ready.
So basically I did something wrong and now I crashed it. But anyway, start was the process running like after when the container finishes. So that process I can show you in a moment. This let me do like instead Docker ps. So mood stage is still here. So if I do ps.a pipe grep start,
yeah,
is it there? Ps pipe grep start. So you see, I just this is all the process running on my computer, and you can see this start script being running as one of the process on my machine. Even it's a container, it will be listed here. So the start is the process spinned by that container.
Yep. Cool. And then the other question we had, Prince is asking some great questions today. Can Foundries delete the older Docker in the RB3 Gen 2 and update it with a new one?
Yeah, for sure. Absolutely. I mean, you can either update the same Docker image for a new version, or like I did in the beginning, remove the complete images that you have and place different containers as a new containers. Yep. So when you see the Foundries UI here, I can literally change and play with all these containers, and I will be able to remove and enable any container I want. If I change this container in the CI/CD, I can also update that container as well.
That's amazing.
Well, just to go like straight for the end, I want to show, like I did this hello world single stage and mood stage. I want to show how easy it is to do like a web application with Flask, like a very simple hello world with web app. Okay. So I wanna let me create a new folder here, Kadir web app, and then I wanna do is I will do a couple of files vi web app.py, and I will copy and paste this so we don't waste too much time. So this is very easy hello world web server with Flask in Python. If you go for Flask Python hello world, that's the example you find. I copy from there, and then I probably change the port number, just that. So to make it easy, if you think about Yocto in general, doing something with Flask, you have to go there, install the Flask, and then you will need to rebuild the distribution. We need to refresh the device or over there update your device, and then you will be able to start playing with Flask. So with container, you can just create a container like I'm going to do right now, Docker file. Oh, let me get the right copy paste. And basically with a couple of code like this, you are starting from a Debian, you install Python, you install pipe, you install the Flask, and then you copy your files, and then you are good to run Python and run that Flask application, this Python Flasking example. So I'm going to do Docker build -- tag web app latest, and here's my Docker file.
Mhm.
Just build my Docker image, and now I'm going to Docker run it. Now I need to specify the port I'm sharing, the network port. And then I will say run in background, and I will name it as a web app and run web app.
Yeah.
App latest. Here we go. Now I do Docker PS to see if my container is running. So I can see here. I can do Docker logs to see if the server is live. Oh, the server is okay. It's running. I haven't to replace the Linux distribution. I'm running the same image. I'm just playing with the Docker apps.
Oh.
And now what we need to do is we need to access the device IP to 999.99.00. And here we have the hello world.
Yes. I love it when a demo goes right.
Yeah, it's very simple actually. But now this example gives me the opportunity to talk about something else, which is a Docker Compose. A Docker Compose is a way to specify the Docker run without being this very long line where you have to pass all these parameters. So if you see these start to become more weird, a lot of commands, but when you have to share a lot of volumes, when you need to have a more complex image, this could become very complicated. And then also when you want to orchestrate one or two containers at the same time, Docker Compose can specify two different images in each image with their parameters.
Yep.
So I want to create a Docker Compose UML and then show how it looks like. This is how it looks like. So basically, this will change. This will replace the Docker run command we just run with specifying the image, the port, and anything that you want to do. And then what I'm going to do is I'm going to write and exit. I will Docker PS Docker. I will remove the running containers. So now we have just the. Let me see. We have just the. Oh, we still have. Here we go. Now we have just the ones I left before, and now I'm going to do Docker Compose up, and what that will do is that will use this Docker UML to run that container.
Can you also do that from the Foundries UI?
Actually, what happened in the backstage is when we update the device, we send the Docker images and all the other Docker information, including the Docker Compose UML to the device, and the daemon running the device, the actualizer light, this one I showed it before.
Yeah.
This one will see this file in the file system, and we will do Docker Compose up, and we'll orchestrate that from there. So we use Docker Compose on all our apps. That's the way we deploy applications. We think that Docker Compose is a very nice way to specify all the Docker, the application for information that you want to send to the device. So we actually do that all the time.
Cool.
And then, like I was doing before, like we run this Docker Compose app, and now the same server is running without having to have this Docker run command. And also a Docker Compose UML is a nice way to also versioning your chains, because like a command line, you will always be able to change, and there is not a nice way to track the chains. Being in a file, you can have version control on every change you do on the way you are running that container as well. So you can track all the chains you are doing. Well, I can test it again. So if I open here and update it again, it's working. And that's about it, the Docker Compose UML. And to finish, I want to show you another application, which is, I let this in the device before. I have another demo that we have run for quite a long time at Foundries. This is the Gen application. Gen, it is Grafana, InfluxDB, and Node-RED.
Nice.
So if we go to the Gen application, we have this Docker Compose UML, which is a specification for a longer file. So if you see here, we have InfluxDB, and then we are specifying getting directly from Docker Hub, the InfluxDB version 1.8. We are sharing this volume with the host file system. We have some environment variables. Always restart when we have a problem. Share that port with the host. Run with privileges. And then when we have Node-RED, we also have the same specification. This depends on this container. If the database doesn't goes on, Node-RED will wait that works.
Yeah.
So depends on this. So it will be a different Docker image running, a different Docker container, but will depends on the InfluxDB. Okay. Then we also have the ports to be shared. We also have like users and then some other environment variables that we need. And then on the Grafana, the same. We have the Grafana from the Docker Hub. Actually, we have the Grafana. We have depends on the InfluxDB. We are building this and this, but we are not building this. This is from Docker Hub directly. Okay. And then, just for you to see how Docker Compose UML could get more complex when you have more containers. And then what I want to do is, it's already running, but I will do the Docker Compose up. It's already running and it's running. And then I want to show how it looks like. So I need to, I stopped it, sorry. Docker Compose, let me put in, Docker Compose -d. I'll run that in background, and then I want to see what ports I have available. So 300 is for Grafana, 1880 for Node-RED. Let's see what that shows me. 1880. So this is my Node-RED flow. It's running inside that container, and I haven't done much. I just launched that Node-RED application, and I have now my flow. I have done this flow before, but I can start playing as I like, and I can play with Node-RED without much force. And then if we go for the Grafana, it was 300. I can see I have this system dashboard, which was open before, getting the data from. So basically what this is doing is, where is that? This is getting data and sending to InfluxDB. Somewhere in here, we have InfluxDB blocks. So it's getting data from the CPU and RAM, sending to InfluxDB. The InfluxDB is another container just for database. Yep. And then we have a Grafana getting this information from the InfluxDB and showing in a nice dashboard.
Yeah, I love Grafana display. It's really helpful for doing reports for higher ups and proving value and whatnot.
So basically, that's about it. That's what I want to show. It's really the basics and how to get started. And one thing that's important, I forgot to mention, the motivation for me to do that training was, I didn't believe in containers 6 years ago. Like, I thought that container wasn't the thing for embedded. Things should be always in the distribution. And then one day I was in a customer who had a Raspberry Pi doing containers. Uh-huh. And then I came with my own board saying, my board, I knew that my board was running container, but I didn't really encourage them to use. And the guy said, if you are running container and you have a distribution with container support, I can try my application right now. And then I gave that device to the customer. He turned it on and he did like Docker run up, and their UI, their dashboard was working. And well, that was where I said, I should start studying again. Because at that time I was working as a salesman for 1 year. And I said, let me get back to and look to that carefully, because that will change the industry. And 6 years from now, we see a lot of people using container, and those who are not using are wasting time, I guess.
Yeah, setting up the platform is huge. We have one last question before, basically you answered this, can Foundries handle Docker Compose? Yes. Can Foundries handle Docker Swarm?
Oh, actually, we do Docker Compose. So if I go back, I could show my UI, but The way we specify application is always with Docker Compose.
Okay.
That's what we use, and I can show my screen again. Let me move it back. Let me go for example.
Yeah.
If we get into the source and then we get a code, we make it bigger. 3. If we get, let's say, maybe not this one. This is a Docker file. This one, for example. This is an example. It's a Docker Compose YAML. I can show you.
Cool.
Let me show you another factory very quickly. Demo. This one, demo 2024.
I love it. We're pulling back old demos to answer questions. I love it.
So this one I want to see if I can display the Docker Compose in live here. So, for example, if I get this. Maybe this one, Flutter assets. Where is that? So you see, like, this is our Docker Compose. We build that application and then we hash them all, put all the hashes that we need, and we use Docker Compose to do that.
Yep. That's really cool. I have one last question from Discord. You mentioned Genie. Is that the only way to run LIM or transformer-based models is through Genie?
I don't recall to mention that. Sorry.
No, that's okay. I heard Genie as well, but I think it was.
I said Gene as GIN, which is the Grafana InfluxDB, and I mean, I'm a Brazilian. You have to give me a break on the accent. It's hard for me. Like, I'm trying my best as well to.
Good. No,
it's a lot of like, for me, the hardest part is like spelling. Spelling is really hard in another language. If someone alive is doing different languages, you will know that spelling is.
Completely agree. I lived in the Netherlands for 10 years. Anytime people told me that my English was really good, it would make me laugh maniacally. Yeah, I appreciate you so much coming in today. This has been a live build along session with Docker and Qualcomm, Dragonwing, RB3 Gen 2. And FoundriesFactory, and Raul, who is amazing and has had no technical issues, with Rain, who has had all the technical issues. But we are going to work on that for our next stream. Yeah, thank you so much for coming today. Thank you for staying longer because we started a little bit later today. And thank you to all of our people who were here watching. Yeah.
Thank you all. It was a pleasure to be here as well.
Yeah, thanks so much. Peace out.